Chapter 1.5.5 Endpoint Slices. Kubernetes v1.21 introduces the Stable Endpoint Slice API, which allows for easier tracking of network endpoints in a Kubernetes cluster. Endpoint slices provide a more scalable and extensible option compared to endpoints. Endpoint slices in Kubernetes contain references to network endpoints. The control plane automatically creates endpoint slices for services with selectors, grouping endpoints by protocol, port number, and service name. Each endpoint slice object represents an IP address type, IPv4, IPv6, FQDN. Conditions such as ready, serving, and terminating provide endpoint status information. Endpoint slices can contain topology information like node and zone location. The control plane manages endpoint slices, but other entities can also manage them using the Managed by label. Ownership of endpoint slices is typically by the service the endpoints belong to. Endpoint slice mirroring mirrors endpoints to endpoint slices to avoid duplicate write operations. Distribution of endpoint slices is handled by the control plane to limit updates. Clients must deduplicate endpoints from multiple endpoint slices associated with a service. Comparison with endpoints. The original Endpoints API in Kubernetes provided a simple way to track network endpoints, but its limitations became more obvious as services grew and handled more traffic. Storing all network endpoints for a service in a single endpoints object led to challenges with scaling to larger numbers of endpoints. The introduction of endpoint slices addressed these issues by reducing the size of update messages when adding or removing pods, resulting in less traffic between Kubernetes components and lower CPU usage. Endpoint slices also enabled innovation for features like dual-stack networking and topology-aware routing, enhancing the functionality of Kubernetes clusters.